Good morning, Abyssers. Starting out with a little Jackson Brown, Doctor My Eyes. You guys ever heard this song?
Doctor, my eyes have seen the years and the slow parade of fears.
Have you heard this?
Now I want to understand.
I play this when I'm sad. I'm sad this morning because I'm not as prepared as I want to be.
I have done all that I could to see the evil and the good without hiding. You must help me if you can.
So let's get to the chorus here.
Doctor, my eyes, tell me what is wrong, 'cause I am wise to leave them open for so long.
All right, that's a good way to start. All right, so you have these notes. It's on section 1.3, and let me just kind of get myself together here. Ooh, we got the squeeze theorem, maybe tomorrow. All right, so this is evaluating the limits analytically, okay? So we talked about graphically looking at points that you're approaching from the left and the right. Would you agree with that? Okay, and we looked at using a table. When you're asked to evaluate them analytically, you can use a graph or a table to see the answer. However, I won't give you credit unless you verify that answer. Analytically means using algebra. Okay, and so we're going to take a look, first of all, at some properties of limits. And I know this for a fact. I know that when I take the limit of some function as x approaches c, some constant, that it gives me a limit. It gives me a number. Okay, I'm going to call that number L. An example, I could say that I know that the limit as x approaches 1 of some function f of x equals 3. Okay, I know that for a fact. And then I also know that the limit of another function that I'll call g of x as x approaches 1, okay, that's approaching the same constant, is going to give me a different limit. Okay, in this case, I'm going to call that limit 5. Okay, so that's what this is saying. We know those facts to be true. Okay, and so we're going to say, all right, what does it mean to have a scalar multiple? So if I have something like this, the limit as x approaches c, and the scalar I'm going to use is a. So a is some number times f of x. Well, that's going to be the same as a times the limit as x approaches c of f of x. And that's going to be the same as a times L. So in my example, if I have the limit as x approaches 1 of 7 f of x, I can say that's the same as 7 times the limit as x approaches 1 of f of x. And so that is going to be 7 times 3, and I'm going to get 21. That's what we mean by a scalar multiple. It means you're simply multiplying by that function by some type of constant. Okay? Next, if I have something like this, the limit as x approaches c, now it says sum or difference, so I'm going to write this. F of x plus or minus, have you seen that notation before? It's the mathematician's shortcut or cheat to be able to write two equations. One I'm adding, one I'm subtracting. And that's going to be the same as of g of x, plus or minus g of x. That's going to be L plus or minus k. So in this case, the limit as x approaches 1 of f of x plus g of x, in my example, would be 3 plus 5 and get 8. That's using this example up here. Yes, sir.
So if you just minus it.
Right, so I'd have, yeah, let me do that. So if I have minus f of x minus g of x, what do you think it would be? Right, it'd be a negative 2. Hi, how are you doing, Maggie?
Good, how are you?
Good, good. Our song today
So,
was Doctor My Eyes.
okay.
Because you know how last year I struggled with coming up with an intro song?
Oh, yeah,
Yeah, I'm stealing them off from the internet. I get a little warning from YouTube all the time. So Elizabeth, you got mail. And Maggie, you'll close the door, right?
Yeah.
All right, thank you. Okay, so and obviously, are you guys okay that if I switch g of x and f of x around, it would be a positive 2? Okay, not bad, is it? All right, so what if we got a product? Well, I get the limit as x approaches c of f of x times g of x. Well, that would be the same as the limit as x approaches c of f of x times the limit of g of x. So I would get L times k. So my example, if I had the limit as x approaches 1 of f of x times g of x, I'm going to get 3 times 5, which is 15. So far, so good? Okay. Okay, so if I have the limit of f of x over g of x as x approaches c, who thinks they know the answer now that I've gone through a few of these? Yes, sir. John.
L over K.
Okay, L over k, as long as k is not what constant?
0.
Right. Okay. 0 causes problems, right? So in our example, the limit as x approaches 1 of f of x over g of x would be what? 3/5. All right. I'm going to slide this a little bit. So you can see a power means you have an exponent. So if I have the limit as x approaches c of f of x to some power that I'm going to call n, it is going to be L to the nth power. So if I have the limit as x approaches 1 of f of x squared, so in this case, n is 2, right? Here, Larry, what would I get? 9. Because that'd be 3 squared, correct? This, now notice, now, if I have this, this is continuous. My domain is what here? My domain is dependent upon n. Would you agree with that? Okay. If n is even. it'd be square root, correct? Fourth root, sixth root, eighth root. X has to be what? Just
Greater than or equal to 0.
greater than or equal to 0. Very good. If n is odd, like the third root, the fifth root, the seventh root, x is what? Can you take the cube root of a negative number? Yeah. In other words, is there a number? And again, I always ask myself, if I stick a negative 1 in there, is there a number times itself 3 times if I take the cube root that gives me a negative 1? Yeah, negative 1, right? It's like the cube root of a negative 8 would be a negative 2, correct? So, and the cube root of 8 is 2, right? So what am I allowed to input if my index, right? Do you guys know this is called an index? Do they tell you that at all? Okay. What if my n is odd? Yeah, it's all reals. Okay. X is an element. Notice that epsilon we use a lot for different things. Reals. So what does that mean? Well, what I will get here, I will get the nth root of C. Now, I'll get the nth root of C if x is greater than 0 when, if C is greater than 0, sorry about that. If C is greater than 0 when n is even. Give you an example. Let's take the limit as x approaches 1, right? Are we okay with that? Of the cube root of x. Can I plug 1 in there and have any problems? Will it cause any problems? Can I take the cube root of 1? Yeah. So my answer is 1. Now what if I gave you this? And I'll write it over here in the corner. The limit as x approaches a negative 3 of the square root of x. What do you suppose the answer for that would be? Does not exist. Because I can't put a negative 3 in there, can I? In fact, if I graph the square root, the square root looks like this. Would everybody agree with that? Do you know that? Okay. Over here is a negative 3, right? Can I even approach negative 3 from the left? Well, there's no graph looking up or down, correct? And if I approach negative 3 from the right, I got to stop at 0, right? Because there's nothing right there, it does not exist. Does that kind of make sense? All right. This one right here, the limit as x approaches C is going to be, first of all, the limit as x approaches C of f of k. Now, how did I get k there? Where did the k come from? Yeah. Right, exactly. When I approach C, correct? Right? So what I did is I put C into here. I know that's going to give me K, correct? So this is going to be some constant. This could be f of K. Give you an example. Let's take the limit as x approaches pi over 2 of the sine of x cubed. All right? So I'm going to put pi over 2 into sine, because sine is continuous, right? It's a wave that looks like this. Doesn't sine look like this? Right? It doesn't have any holes or asymptotes or anything. It just goes up and down. So what is the sine of pi over 2? 1. Very good. You said that quickly. What's 1 cubed? 1. So my limit is 1. Cullen, we okay with that? Okay. Can I go on the next page? Okay, so now we're going to get to the algebra part. And so over here, I'm going to write a little note. I'm going to say successful steps in finding limits algebraically. One. The limit of any constant is that constant. That's the first thing. So I believe that taking the limit of a constant is really easy, and for some reason, students find it hard. You know why they find it hard? Because Marie and I do a poopy job of explaining it. Okay? So let's take a look at this one right here. We're approaching pi, and our function is 15. Okay? So I'm going to first show it graphically. Everybody okay with that? So this means f of x equals 15. Because that's some function in there. My function is 15. Okay? Which is the same as saying y equals 15. Correct? Because f of x and y are synonymous. Okay, Jeremiah? Now, what does the graph of that look like? It's a horizontal line, right? And this is y equals 15. So here's 1, here's 2, here's 3, here's 4. Pi somewhere right here, correct? I am approaching from the left. Boom. Approaching more from the left. Boom. Approaching more from the left. Boom. Correct? And if I'm now approaching from the right, boom. Approaching from the right, boom. Does my y ever change? It's constant, correct? It's always at the same height or depth if it was negative, correct? So the answer to this is 15. In fact, the limit as x approaches any number of 15 will be 15. Are you all right with that? Now, number 2. The next step is substitute if you can. I was really good at substitution. So I would take a look and say, all right, all I got to do is put 4 in there. If it does not cause any problems, and what I mean by causing any problems, division by 0, correct? Or square roots are a problem, correct? Right? Would you agree? Square roots and division of 0 are problems. If that isn't a problem, then what I am approaching is that number that exists in the function because it's there. Does that make sense? So what I'm going to do is I'm going to put 4 in here and cube it. So 4 times 4 is 16, correct? What's 4 times 16? 64 plus, times 2. Very good. Plus 1. I'm done. Now, do I have to show my work for this one when you have it on the quiz on Monday? No. Do you have to show your work for this one? No. I'm not at the level where you have to show me that 4 times 4 times 4 is 64, times 2 is 128, plus 1 is 129. I'm assuming you did that on your calculator. If you don't know that 4 cubed is 64, correct? So there's no work to be shown on here. There's no work to be shown on here. How about this one? If I put a negative 1 in here, do you see I get 0 over 0? I have issues, don't I? So I go to step 3. Factor. If possible. Or divide. Now, I've talked about this one a couple of times, correct? Am I right on that? Well, I can't substitute, correct? It's not a constant, correct? So I got to factor. That's what I'm looking at. Can I factor? I can't factor the bottom, right? Can I factor the top? In other words, I'm going to rewrite this limit as x is a negative 1, and I'm going to write this, x plus 1 down here. Now notice how I'm showing my work. I'm writing the limit. I have to write the limit. What do I get as a factor of x cubed plus 1? X plus 1 and another factor. Hillary, do you remember what it is? You only have to say yes or no. Not exactly. Do you know the first term? Okay. X squared is the first term. Okay? Perfect. Do you know the last term? Okay, good. There's 2 more terms because it's a trinomial. Does anybody know what the next one is? What? I think you're saying minus x. That's correct. The minus x. Then it's plus 1. Now, how do I get the minus x? I just multiply these 2 terms. I have to make it negative. I only have 1 minus in this product. Okay? Now, this simplifies, doesn't it? This was the thing that was causing the problem because it was in the denominator, right? Oh, by the way, sorry. Okay. What replaces it down here? A 1, okay? You don't have to show the 1. I'm doing that as a teacher so you know there. So can I now put a negative 1 into here? I should be able to. I don't have division by 0 anymore, do I? So it's a negative 1 squared, 1, minus a negative 1. I'm up to 2, aren't I? Right? because it's a negative 1, excuse me, it's 1 minus a negative 1. That's 1 plus 1, correct? Plus another 1. What do we get? Isn't that amazing? 3. Are we okay with this so far? Okay, now I'm going to use this example. My original function was this. Oops. Right? That was my original. This graph looks like this. So if I put 0 in here, I'm at 1, correct? Right, would you agree? If I put 1 in here, I'm at 9 halves. Would you agree? Put that right here. If I put a negative 1, I'm at, negative 1, I can't put a negative 1 in there, can I? But I would be, if I could, I'd be at, excuse me, when I put, if I put a negative 1 in here, if I could, I'd be at a negative 3. So there's a hole here, correct? So my graph, here, let me show you what I mean by my calculator. I'm doing a poor job of explaining. I'm going to show you how to use the graph. I'm going to have parentheses, x cubed plus, oops, plus 1, parentheses, divide, parentheses, x plus 1, parentheses. Oops. Let's go shift my window and let's make it a standard window. Exit. Let's draw again. There's my graph. Okay? But that graph is a lie. You know why there's a lie? Shift trace. Get a negative 1. What does it say here? Error. Why is it an error? Because it doesn't exist, correct? Right? And if I would go to my table, and I would put a negative 1.0001, I'm really close to 3, correct? Can you see that? And if I put negative 0.9999, I'm really close to 3, correct? But if I put a negative 1 in there, I better get an error, correct? Right? So my real graph looks like this. There's a hole here. It looks like a parabola with a hole, correct? Why? Because a negative 1 doesn't exist. Would you agree with that? There is a hole there. I will ask you to graph this. You better have your hole there, right? Like that. Now, I'm going to graph that. That's a different equation than this, isn't it? I'm going to graph it. Guess what? It looks exactly the same. Exactly the same. Except for what? There's no hole. right? Because I'm allowed to put a negative 1 in here. So this equation right here, the limit as x approaches a negative 1 of x squared minus x plus 1 is a substitute for this because this has no hole, correct? They're going to look the same. They have exactly the same y values except at one point, at a negative 1. Because the negative 1 is not part of the domain here. It is part of the domain here. I cannot input it here. I can input it here. Is that making sense? Okay. So let me give you another one. And I'm going to put it at number 5, and then I'm going to come to number 4. Okay? Notice I got some blank ones. You ready? The limit as x approaches 2 of x squared minus 4 over x minus 2. The first thing I do, is it a constant? No. Second thing I do, can I substitute? No. Third thing I can do, can I factor? Okay, so I'm going to write equals limit x approaches 2. I'm going to write x minus 2 here. What does the top factor 2? X plus 2, x minus 2. And then I'm going to simplify, right? What's my limit? Well, okay, I got x plus 2, correct? Down here it's 1, right? I don't have division by 0 anymore, do I? I am taking the limit of this. I'm taking the limit as x approaches 2 of x plus 2. What do I get? 4. This is the substitute equation for this. These are exactly the same values except for 1 at x equals 2. Is that making sense? Because the domain here, I can put in 2. The domain over here, I can't put in 2. Yes, ma'am. That's, you know what? That's a wonderful question. Okay. I'm going to, and this, I'd love to graph that one, wouldn't you? That's the one I'm going to graph. Right here. You see I have that point? Right? Because I could put 0 in here and I could put 0 in here. In fact, if I put 0 in here, I get negative 4 over negative 2, which is 2, correct? If I put 1 in here, I'll get 3. If I put 1 in here, I'll get a negative 3 over a negative 1, which is 3. Now, when I put 2 in here, I would get 4 here, but in here, what am I going to get? It doesn't exist, so how do I show that? I put a hole. So here, my graph is a line, Marine. The graph of this is the same as the graph at this, except it has a hole. Except it has a hole. Are we okay with that? Now, here's my other question. Can I move on a little bit and talk a little bit more about holes? Holes versus asymptotes. They look a lot the same. I'll give you an example. X squared minus 4 over x squared plus 4x plus 4. I'm going to factor both of these. I think you're okay with this. And I think you're okay with this. Actually, I'm going to change this one. Do you mind if I change this one? I'm going to make this 5x plus 6. Are you okay with that? I'm sorry. So I'm going to have x plus 2. I'm going to have x plus 3. Right? Have you ever done a problem like this, simplified it? Okay. Now this is what's going to happen, right? Correct? So what is at x equals a negative 2? Because I can't put a negative 2 into this function, can I? I'll get 0 over 0, right? If I put negative 2 up here, I get 4 minus 4. And if I put negative 2 in here, I'll get 4 plus a negative 10 plus 6. I'll get 0 on the bottom. Would everybody agree with that? So a negative 2, it does not exist, correct? What's there? Does anybody know? What was that 2 here? Guess what's at a negative 2 here? A hole. This makes a hole. Why? Because it was simplified. Is it discontinuous at a hole? Yes. What's at x equals a negative 3? It didn't get simplified. What's got to be there? An asymptote. Because it did not get removed by factoring. Is that making sense? Now, there's some big difference between holes and asymptotes, especially when we talk about taking limits. Can we take a limit of a hole? Well, here's a hole. Did we take its limit? Yeah, it was 4, wasn't it? If I have an asymptote, it's either going to do this or it's going to do this, correct? Is there a limit at an asymptote? No, it doesn't go to a number. Here, I can go here and head this way. I can go here and head this way, and I'm really close to 4. I can't do that here. As I get closer and closer to a number, I either go further down or further up, correct? It goes to positive or negative infinity. Would you agree with that? So holes always have limits. Asymptotes don't have limits. But they're both discontinuous. Does that make sense? We got to kind of think that way. And that's how that looks algebraically. Am I doing okay explaining that? Alrighty. Now I'm going to number 4. And I didn't leave myself room. 4. What would be my 4th step? Radical? Question mark? Multiply by conjugate. Sorry about that. So I have a radical, correct? If first thing I still go through my steps, Carter. Not a constant, right? X is involved. Okay. Can't factor, right? Because the radical scares the bejeebers out of me, right? I see a radical, so I'm going to in fact, it's a square root, isn't it? Right? McKenna, you'll always have square roots. So I'm going to multiply by its conjugate. Times. I'll make that equals and make it a times. And it's going to be the square root of x plus 4 plus, why did I choose plus? Because this is minus. Plus what? 2. And down here, I got to multiply the bottom by the same thing. Are you all right where I got that conjugate? So this is going to become, notice I'm rewriting the word limit. Now, down here is going to be icky, and I'm going to leave it icky. I'm going to write parentheses, square root of x plus 4 plus 2. What does the numerator become? Well, what is the square root of x plus 4 times the square root of x plus 4? What happens when you do that? Sawyer, do you know? You want to take a chance? Yeah, right. The square roots eliminate each other, right? Like the square root of 2 times the square root of 2 is 2. Square root of 3 times the square root of 3 is 3. You get that radicand. You get x plus 4. Now, what do I get when I take the, right? There's no inner or outer, is there? Right? It's just the two ends with a minus sign, correct? Right? That's the beauty of conjugates. And to be honest with you, if my brother, older brother or sister were listening, my twin brothers are really cute. They could even be described as beautiful. You should see them. You'd go, oh my gosh, they're unbelievable. Perfect. All their hair, none of it gray. Nice and trim. So this is going to be minus what? 4. Is that a good thing? Why is that a good thing? It gets rid of what? Well, first of all, 4 minus 4 is what? 0. Boom. That's done, right? Correct? And so I have x plus 0, right? Which is what? X, correct? And I had an x here, and that x was causing problems, Elizabeth, because it was 0, right? So does this x and this x simplify? Right. So I get rid of the thing that's causing problems. Now, I crossed a whole bunch of stuff, Cullen, on top, right? I got rid of a bunch of stuff. Does that mean there's nothing on top? No, that's a big mistake people make. They put a 0 on top. There's really a constant on top. It's what? 1, exactly. There's a 1 there. And a very common mistake, bam, I got rid of this. Bam, I got rid of this. Hannah, are we doing okay?
Yeah.
Okay. So now can I put 0 in here? Well, I'm going to get 1 over 0 plus 4, which is 4, correct? Right? Square root of 4 is, and 2 plus 2 is 4. Bingo. There's my limit. All right. Let me give you another one. Gavin, can I substitute 4 in there? No. So what are you going to multiply by? And I'm going to put parentheses on the bottom. Is that okay with you? So I'm going to get the limit as x approaches 4. Did you guys multiply by radicals at all last year? Yeah? So, Hannah, what am I going to get when these radicals multiply? Minus what? Negative 3 times a positive 3. Okay? And down here I have an x minus 4 in parentheses, and I have square root of x plus 5 plus 3, right? So what is x plus 5 minus 9? X minus 4. Bam, correct? And I'm left with a 1. So what is my limit? 1 over what? Yeah, but can I put 4 in there now? What is 4 plus? That's all right. That's all right. It's morning time. It's not even noon yet. So what is it? 1 over 6. Now, here's how you can check your answer. You could put this in a table, correct? And you would get 1.1666667. So you would know the limit would exist, and then you could take 1 divided by 6, and you'll get 0.16 repeating. Maybe on your calculator end with 7, right? Or you could put it on your graph it and trace it, and take a look from the left and the right, correct? Is everybody with me on that, how you could check? All right, number 7. That was number 7. Number 7. So step number 5, which I'm going to put right here. Simplify rational expressions. In other words, fractions. And so I'm going to show you this one. The limit as x approaches 0 of 1 over 3 plus x minus 1/3 over x. Now again, I can't do substitution, right? Because you'll get 0 in the denominator. There's no radicals, Maureen, so I'm not multiplying by conjugates. You only multiply by conjugates if there are square root symbols. But I have fractions, don't I? So I'm going to get a common denominator. The common denominator is the product of these two denominators. Just like if I had 1/4 and 1/5, the common denominator is 20, because I took 4 times 5. Okay? So now I'm going to rewrite this. And hopefully I don't get you confused. So I got to write this here, over x. So I multiplied this by 3 and this by 3. And I multiplied this by 3 plus x and 3 plus x. Sorry about that. And I'm getting this. Are you okay with that? So now I'm going to write this. I'm going to cross out my 8. I got the limit as x approaches 0. Let me know if I'm going too fast. Three minus x over 3 times 3 plus x times the reciprocal of x. What's the reciprocal of x? This is x over 1, correct? So the reciprocal is 1 over x. Now, let's see what happens. Bring out the red pen. What's 3 minus 3? There's a 0 here, correct? What's 0 minus x? Negative x, correct? More blood. Oops, that's what the red represents, by the way, is blood, if you haven't figured it out. Guess what these are? Drops of blood. I've been watching Fargo a lot lately, okay? Anybody watch Fargo on FX? See, I need a certain amount of violence in my life just to keep me calm. I know that sounds weird. I used to have a buddy, a good pastor friend of mine. We've been friends for, oh my gosh, 57 years. Since we were 3. And he's a pastor. We go to violent movies like Django Unchained and The Hateful Eight. We just laugh. So anyway, we got off topic. So this is a negative x, this is an x. They also can be simplified, right? It'll become what up here? Negative 1, right? Now, this is the x. Would you agree that was causing problems? And it has been removed, hasn't it? So this function, a negative 1 over 3 times 3 plus x, is an identical function to the previous one, except it has no hole, right? I knew this was a hole because I was able to factor it out. I was able, simplify it out, correct? So now I could put in 0. What do I get as a limit? It's negative, right? 1 on top, right? 1/9. So that is the value I get. That's where my y values are moving towards as I move my inputs closer to 0. Does that kind of make sense when I say it like that? That's where my y values are headed as I move my inputs towards 0. I can't be at 0 because I got problems. So I get really close to 0. All right. How much time do I have? Are you guys? I'd like to get to 10 and stop. Is that okay? Because then you'll be able to do a significant amount of work on 1-3. That would be helpful. Okay. And then I could talk about the trig ones and finish up tomorrow. And then I'll do the squeeze theorem tomorrow. Okay? I got 12 minutes? Okay. So let's look at number 9. Because I've been talking a long time. And I know how when teachers talk for a long time, it's pretty soon it sounds like blah, 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 blah. If you ever watch Peanuts, the cartoon, blah, blah, blah. That was true for me. So I try to break it up and tell some stories. And I don't have a story right now. except for my beautiful, good-looking brothers. So, yeah, because I need room. This will be 8 right here. And then this will be 9 right here. Is that okay? Okay. So here's this one. I'll choose this one. They kind of look the same. The limit as x approaches 0 of 1 over 3 plus x minus 1/3 over x. Oh, we just did that one. Sorry. 2. Sorry about that. Okay, do you see? Can I make a jump to here? That's how I show my work. Like I showed you all the steps on how I got there last time, right? You see where I got here? I multiplied this by 2. That's where this 2 comes from. Then I multiplied this numerator by 2 plus x. But the reason it's minus 2 and minus x is because that minus sign or subtraction symbol. Are you okay with that, or is that too big of a jump? Brady, you okay with that? Okay. I don't want to do something you think I just pulled it out of thin air. So what's going to happen is all of this is going to be gone right here, and there's a negative 1 here. Because 2 minus 2 is 0, and then I'll have 0 minus x, which is the negative x, which simplifies with this x, and I have a negative 1 that's left. Don't think it's 0, folks. Like I said, I see too much of that. So now you should be able to see that the limit is what? Now I should be able to put 0 in there. And I'm going to get a negative what? 1/4. Okay. All right. All right. So this is where we're headed to. And so I'm going to give you some choices of how you want to do this. But this is how it starts. The limit. And what I'm doing is I'm doing some problems that are out of the book that are similar to, so I assigned you ones. So the ones that I'm doing are the ones that are right next to the ones that I think you're going to have problems with. And you'll go, oh, they're in the notes. Oh, I'll watch it on videotape because I don't understand any of his notes and look at him. He's a mess. Okay? So here it is. Here's our friend delta x. And delta x is going to 0. It's just a variable that's getting smaller. I'll make it nice for you if you're anti-delta x. Some people like delta x because it's kind of like Greek and they kind of get into the Greek. And so what I'm going to have, this is a little too crooked for me, and I'm going to change this to x plus delta x squared minus 2 times x plus delta x plus 1 minus parentheses x squared minus 2x plus 1 all over delta x. Now some people don't like delta x and they replace the delta x with h. In fact, in the book you'll see h quite often instead of delta x. So I'll put the h in there. Okay, and so it's going to look like this. The limit as h goes to 0 of x squared plus 2xh plus h squared. I'm going to pause there. So I took x plus h and I foiled it in my head. The biggest mistake is people write x squared plus h squared and don't have that middle term. That's a voodoo stamp if I've ever seen one. Is that better, Cullen, if I raise it up a little bit? Okay, you see it now? Okay. So this is this, with just the delta x removed and replaced by h. Did I get you really confused by doing that? Okay. So now it's going to be minus 2x minus 2h. I just distributed the 2, the minus 2, plus 1, which a lot of times people forget, minus x squared plus 2x minus 1 over h. Brady, okay? We got a bloodbath going on here, Brady. Bam, bam. Bam, 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 bam. Just a pool of blood all over it. Okay? Right? Now, notice each of these terms that's left has an h in it, correct? So I'm going to take, and I'm going to rewrite this as the limit as h goes to 0. And I'm going to factor out an h, and I'm going to get 2x plus h minus 2 all over h. So I took the h out of here, the h out of here, and the h out of here. Are you okay with that? A little bit more annihilation. The h that was causing problems, that was causing division by 0, is gone. Would you agree? I'm not substituting 0 into x. It tells me I'm substituting 0 into h, correct? So this h is going to be getting closer and closer and closer to 0 and have no effect left. So in this case, my limit is an equation and not a number. We're going to talk more about that in chapter 2. Okay? Because it's going to represent something. So I'm going to get as an answer 2x minus 2. This equation is going to give us some important information. Okay with that? I didn't blow you out of the water? You don't got like a massive headache going, oh my gosh, I think I'm going to die? Ryan, do you have a question? We're going to say it louder so. Are we okay? Okay. All right, you guys have been wonderful. Goodbye, people.